Hello guys, good afternoon. My name is Mohammed Sabir and today I am here with you. In these sessions, we are going to start a air refrigeration cycle. Basically, we have a three cycle, basically a Joule Breton cycle, Bell-Coleman cycle, and COP Bell-Coleman cycle. We'll discuss these three topics. Like first, you have studied the vapor compression cycle. Basically, it is the extended form of vapor compression cycle. The physics is totally same as vapor compression cycle. Okay, there is no principle, there is no change in the working principle of a system. Basically, only we are only changing the refrigerant. Like here, we are using the air as a refrigerant. Okay. In the Joule Breton cycle, in a Joule Breton cycle, it basically a power generation cycle. Here 1 to 2 is basically compression, isentropic compression, and 2 to 3 is for isobaric heat additions, and 3 to 4 is what isentropic uh, expansions, and 4 to 1 is for the isobaric heat extractions. And now we come to the this is the basic uh, Bell Coleman cycle. Like here the ideal air gas refrigeration cycle. Okay, here two is the two process two process for uh, two process of the isentropic, and another two for another two is another two are the isobaric. Okay, like 1 to 2 is done by the compressor is basically isentropic compressor, and 2 to 3 is for what isobaric heat extractions, basically is which is done by the cooler, and 3 to 4 is what isentropic expansion, which is done by the turbine, and 4 to 1 is for what 4 to 1 is for what basically here we get a refrigeration effect, which is the isobaric heat additions. Okay, which is isobaric heat additions. Okay, now come to the like how to analyze, like how to find the mathematical expressions. Here we have a two isentropic processes. Like we use a PV raised to gamma is equal to C, and by using it we can easily find the uh, these all state of the processes. Okay, this is very so simple task. Use FLOT, and this is the use FLOT, and basically for to find the compressor work done, we use a minus 1 to 2 VDP. Basically, it is the process for what expansion devices is the work for the expansion flow devices. But here we have a compression device, so we use a plus sign like DW 122 VDP, and you solve it and you find that this is the work done. Basically, is for compressor CP CP minus T1. Basically, CP2 minus T1 is the work done for the compressor. Okay. Now we come to the COP for the system. Okay, like how we find the COP, basically we have a 3 to 4 is like 2 to 3 is the isobaric heat extractions, and 4 to 1 is the isobaric heat additions. So easily we can find the heat interactions. Okay, COP of the system is CPT1 minus T4 upon CPT2 minus T3 minus CPT1 minus T2 is. So it's a very basic thing, because here we use a network. Here we use a network that basically uh, like uh, in a like basically we subtract the compressor expansion work done from a compression work done. Okay, and like accordingly you can find the COP of the system, and how we convert into the pressure ratio and use a P raised to gamma C, and by using easily you can convert into the pressure ratio. Why we are using a pressure ratio term? We are like we are going for the pressure ratio term in the CU expression of CUP because in a practically as a practitioner we have a data of a pressures. Because of that we are looking for that. Okay, you know, now we'll come to the actual cycles. In this cycle, we are using these old. We are assuming that these all processes are the reversible processes, and these all are the. There will be no irreversibility, but in a practical case, irreversibility is there. Compression expansion processes are no isentropic. Pressure drop in the cooler due to friction. Pressure at the outlet of expander is greater than the inlet. The pressure at the outlet of the expander is greater than the inlet pressure of the compressor. It's a basic thing. That the pressure at the outlet of the expander is greater than the inlet pressure of the compressor. It's some pressure loss will be there because of that. The 1 to 2 process basically 1 to 2 is basically you like a for 1 to 2 we use a polytropic process. Okay, to define P raised to power n is equal to C. Okay, this is the reversible process in P raised to n is equal to C. But here we are adding the some irreversibility. So because of that we are adding some factor like we define isentropic isentropic compression efficiency, isentropic expansion efficiency, turbine efficiency. By using that, like, we have some factor. By using that, we easily calculate the state of the system. Okay, now we come to the. This is the so simple thing, and now we come to the air refrigeration cycle. Like how to, like why we are using a refrigeration cycle for aircraft. When we uh, go upside in environmental, what basically happen, temperature rises, still we are using the refrigerations because the reason is so simple because you know the air which is uh, passed through a aeroplane having a speed something around like corresponding to that speed the temperatures uh, comes like approximately 30 degrees Celsius. So, because of this temperature increment, we have to cool it. For what we are using the for this we are using the refrigeration cycle, and the solid addition is also there. Some control devices like they release heat, and because of that we are using it. Like why we are using air. Air is the free environmental safe, non-toxic air cycle equipment is extremely reliable, reducing maintenance cost and system downtime. The performance of air cycle unit does not deteriorate as much as that of liquid compression unit when you operating away from it. Like you can say, like off-design process of the air refrigeration cycle is high. When operating in a refrigeration cycle, the air unit can also produce heat at a huge full temperature. If this is used together with the cooling highly efficient, low energy processes are possible. If this is used together with the cooling, highly efficient, low processes are possible. You can say like uh, basically we are using this. We are like using air as a refrigerant. Okay, in the refrigerant cycle also like we are installing only one compressor for the system. The one compressor do basically two work. One for the main power generation cycle and another for the refrigeration cycle. This is the practically advantage of the air refrigeration cycle. Okay. An advantage of air cycle for aeroplane refrigerations: no cost of refrigerant involved, quite cheap. Main compressor of gas turbine is used. Chilled air is direct use for cooling. Minor leakage is not a problem. Low pressure in the system. RPM of compressor is so high. Air is non-toxic, non-flammable. Refrigeration system is light in weight. Okay, disadvantage of air refrigeration system: low coefficient of performance, sensible heating of refrigerant, and freezing of the moistures. Okay, now we come to the how we categorize the air refrigeration cycle. Basically, we can categorize it into the four parts. The first is the simple system, another is the bootstrap, and third is the regenerative, and fourth is the reduced ambient system. Oh, basically, in a first system, what basically we are looking, we have this air refrigeration system. Like in this, for aircraft refrigerations, basically we are we modify the uh, Bell Conman cycles. Okay, okay, like how? Like first, in a 0 to 1 process is the basic is for what? It basically is for the ramming of the air. Ramming of the air, you can say like when air enter into the state one, what basically having so much high velocity. Basically, this velocity is converted into the enthalpy. Okay, because of that, what basically happens, that we get a temperature, we get a high temperature. Okay, and at state one, the velocity of air, like it basically uses on kinetic energy, and whole kinetic energy is converted into the pressure energy. Okay, because of that, the temperature rises. Okay, then 1 to 2 is compressor. One to two is the for the compressor, and 2 to 3 process is basically a uh, you know 2 to 3 is basically a cooling process, and 3 to 4 is like expansion, and 4 to 1 for the cabin. Okay, like whatever work we get from a turbine is basically used to run a fan for the cooler. And in a boost air refrigeration cycle, basically we are installing a one extra compressor, okay, and one extra cooler. This is the basic difference between bootstrap and simple air refrigeration cycle. Okay, and then come to the bootstrap with uh, like we provide a cooler uh, in a 4 to 6 process. What basically happens, the temperatures go down, the temperature goes down 4 to 6. Because of that, we can get a more refrigeration effect. Because of that, we are using this cooler. And another is for like air refrigeration cycle with regenerations. Regeneration is what you like whatever whatever like air which come from the expansions, like expansion device turbine is basically used to cool the air which comes from the process 3. Like that at state 3, air having a high temperature, at state 5 the air having a low temperature. And then what basically happens, it basically it basically flow from high temperature to low temperature because of this principle. The state 3 basically uses energy to deliver energy to the air having a state 5. And now we how we aid the irreversibility in the airplane refrigeration cycle. The first thing is that how to deal with 0 to 1 case. H1 is what? H naught plus C naught square by 2. H1 minus H naught C naught square by 2. CP T1 minus T naught is equal to C naught square minus upon 2. and basically C naught square by 2. A Cp, how you can write a Cp is what? Gamma minus 1 R. You can say T1 minus T naught is equal to 1 plus gamma minus m R is m square. This is basically a Mach number. M is, if the m is greater than 1, is the Mach sonic supersonic. Like by using Mach number, we define a sonic and supersonic conditions. And practically what basically happen, pressure reduce factor. you know uh, like we are expecting that if we get this much of pressure, but in reality it comes it comes down, and how we define this factor, p1 minus p naught, p1 minus p naught. This is the actual, this is the we are ideal pressure difference, and p1 dash minus p naught basically realistic actual pressure drop. And now comes to the P1 to P2, what basically happens, uh, you know, T2 minus T1, delta C T2 minus T1, T2 days minus T1 days. Like is the isotropic efficiency of the compressor. T2 minus T1 is for what? Is the ideal work done. And T2 days minus T1 is for what? Is basically a actual actual work done. Ideal upon actual, it gives the isotropic efficiency of a compressor. And actual actual upon ideal, it gives the isentropic efficiency of a it gives the isentropic efficiency of a turbine. Okay, then come to the topic, that is what, basically, this is the actual vapor compression cycle. you know what basically happen, when uh, basically the refrigerant comes into the, basically happen, you know okay, now comes to the how to identify, like how to analyze the actual vapor compression cycle. you know air having, like air has at a state 1 basically having a low temperature. it basically when when interact with ambient air, some heat addition will be there. Due to that, basically the state 1 shifted to state 1a, like having, you can say, some heat addition is there. And 1 to 2, this is the basic actual cycle. I think uh, we will look in the next sessions. Okay, for today's sessions, we are stopping here, and all the best. These remaining slide, uh, we can take in the next sessions. Okay, thank you, all the best.